systems lifecycle management. We're going to be going over various Ansible approaches and modules to transform and manage your systems using Ansible. So, kind of an overview of what we're going to cover in this chapter. We're first going to start with managing users, packages, and application content. So we've got some example code written up that we're going to deploy in real time, like we did with all the other chapters. We're first going to cover how to create and manage local users on a set of disparate remote systems, including managing SSH keys. Later, we're going to cover ensuring that the latest version of your services or packages are up to date. And if there is a new version available, you will upgrade it and then restart the service if needed. And lastly, in this subsection, we're going to cover deploying static and dynamic web content using the copy module as well as the template module in Ansible. Moving on from this, we're going to go over the differences between using sort of a quick and dirty standalone playbook to using what's called a multi-role playbook. So the example here, and sort of sticking in theme with the rest of the course, is we're going to be dealing with web content. We're going to be deploying and managing a set of static web servers that accomplish managing all of the above things that we just talked about. But we're going to show you sort of the differences between a standalone quick and dirty approach, where you're dealing with one playbook, and more of a multi-role or stack playbook where you're calling multiple roles from one playbook. And we're going to show you why that's usually a better approach to grow into. Lastly, systems management would not be complete without touching on Ansible Tower, or the open source version of Ansible Tower, the upstream version, Ansible AWX. Lastly, we're going to briefly touch on CI/CD and testing. Okay. So let's jump directly into managing users and credentials. In general, in larger infrastructures, or really in any sort of organization, you're better off using centralized authentication. This could be FreeIPA, LDAP, Kerberos, or Microsoft Active Directory, or any number of cloud-based solutions are available as well. I believe FoxPass is one of these kind of LDAP as a service startups. So there's lots of solutions for the centralized authentication front. But for this chapter, we are going to focus on managing local users and using SSH authentication. This is going to be a little more directly useful in a development environment, but in general, you should have some access method into your systems besides centralized authentication, because that can sometimes become unavailable. So regardless, this is going to be useful. The modules that we're going to be covering today are going to be the user module, and this covers all aspects of local user accounts on Unix and Linux-based systems. We are not going to cover Windows, but there is equivalent Windows functionality in Ansible. The win_user module exists for doing the same thing basically on Windows systems. The second module in our arsenal today for managing users and authentication is the authorize_key module, and that's going to manage our public SSH keys to ensure that our remote users have the right authentication credentials associated with them. Okay, so let's look at the basic construct of the user module with Ansible. The syntax is pretty simple. You're going to define the name of the user. You're going to define a shell that you want. You can also specify if you want to generate your own SSH key, as well as some aspects of that SSH key, like the encryption strength and the actual name of the key. Okay, so let's take a look at what that looks like in code. So in this directory here, I have what we would call sort of the standalone approach. I've got a few playbook files that we're going to cover. So this is more of a decentralized approach. It's not going to be the multi-role that we've talked about. But let's go ahead and look at what this looks like. So I'm going to do a few things here. I'm going to first run a local command called whoami on my system, my remote system that my local system that I'm using, and it's going to tell me who my local user is. And I'm going to use that as a variable. I'm going to register that, the variable your user, as whatever the command whoami returns. That's important because I want to add my own public SSH key as long as any of the ones that I need to add for, say, other people. This is the code that we just looked at. We're going to set up a system user called example user. Now notice the shell that I'm using is /sbin/no-login. This is pretty common for what you would call service users, where a particular local user is going to run some service or application, but you don't want to grant console privileges. You don't want to let that user be allowed to remote secure shell into the system. Okay, so now we're going to look at the authorized key module, and this goes along in tandem with the user module. And we're first going to drop down keys of additional people that we want to have associated with this example user once this example user is created. So the key equals lookup file and then authorized keys. This authorized _keys file is something that you would keep in your Ansible playbook. You would keep this as a standalone file. And really kind of the idea, the best practice around this is to manage this, like many things, to manage this in an SCM like Git, where you have revision control and optionally you have CI and CD checks and things like that to make sure that the syntax of the code that you're managing and the resources that you're managing is correct. So the other thing that we want to cover here, and we just saw the local _action command to figure out what my local username is on my system right now, because I want to copy my key as well. And the only difference between using the authorized _key module with, say, a file that contains other people's public SSH keys is instead of calling file down here and then saying authorized _keys, I'm actually going to take the standard out variable output of what whoami is. So this is going to extrapolate into /home/wfoster dot standard out. So this will basically be constructed here as /home/wfoster and then the location to my public SSH key. And we can see this down here. So these are going to be the two that manage this for us. All right. So let's run this and see what happens. We've got two web servers set up, host 01 and host 02. These are common VMs that we've used throughout the course. And let's go ahead and run this standalone playbook that's going to create our users, and it's going to drop our keys down. -I hosts. All right. So let's run this. And what it should do here is it's going to figure out who our user is. It's going to create the example user, the local username example user, on these two remote systems. It's going to add our SSH keys. And it's going to add the other SSH keys that we have listed in authorized _keys. But if we take a look here, there's no keys. But if you were to, say, manage credentials for a set of developers or a subset of users, then you would simply just paste their public keys into this file. And all you would have to do at this point is only manage this file to add or revoke access to the target systems. All right. So let's go ahead and SSH into this host, and it's not going to let us. And we're going to run the hostname command. Oh, well, it did let us. It's because I have my key added as root. Let's run as example user. All right, so it says this account is currently unavailable. The reason for this is that our shell for the example users is set to sbin no login. It's doing what it's supposed to. Let's change this to a valid shell. Let's change this to /bin bash. Now the idempotent way that this playbook is made is that It's not going to need to set up a new user again because it already exists. It's not going to need to add the keys because they're already there. What it should only do at this point is be smart enough to say, hey, wait a minute. You now want the shell for this example user to be bin bash instead of /sbin/no-login. So what it should do when we run it is it should actually just run the chsh command, but you don't have to figure that out. Ansible will do that for you. So let's run this again. And the only thing that it should change, besides, of course, every time it runs a local command, it says something changed, is it right here. It changed the shell of the user. Let's run it again, and nothing should happen. And this is sort of the way that you want to have your playbooks done. Repeated runs of the playbook should never change anything once the system is in its desired state. All right. So let's try to get into the system again as example user. Excellent. We were able to get in and we were able to run the hostname command. All right. Managing packages and services. Probably one of the most important uses of Ansible for managing your systems is ensuring that all of your services and packages are both installed as well as running the latest version. Like the other chapters in this course, we're going to be using the Apache web server as an example. In this case, we're running a Red Hat-based Linux distribution. We're running CentOS, so we are using the Yum module. If you were using a Debian or Ubuntu-based distribution, there is a similar one called the apt module, but we're not going to cover that. For illustration purposes, we're going to stick with the Yum module. So what this does is it will install the Apache web server if it's not installed, or if it is installed, it will ensure that it's the latest version. So down here, we're going to basically cover HTTPD, which is the name of the Apache package, as well as the mod SSL package, which provides SSL functionality and libraries for Apache. And notice here we have our handler. If you remember back from Chapter 4, we use handlers to restart services only if there was a change made to that service. So we're going to be calling as well the Apache handler that's going to restart Apache if it detects that there needs to be a restart. Lastly, we're going to be using the service module, and we're going to just ensure that Apache is running. So for, say, the first time that a system is deployed, Apache's not going to be running once it's installed. So this is going to ensure that it's running. But also, if it's not running when we run Ansible again, it's going to ensure that it is indeed started. And again, here is our handler from Chapter 4. Very simple. We're going to restart Apache if we need to. That's the beauty of handlers. So let's take a look at this in a standalone playbook format. So because this is a standalone playbook, this has to be included at the top of every playbook. And then here's our handler that's going to make sure that Apache is restarted only if it needs to be. And then this is the code that we just covered here, right here. Okay, pretty simple. Okay, managing application and service content. The second part of this functionality is that not only do we want to make sure that we have the latest version of our services or packages present on the system and running, we also want to manage the actual content that these services provide. So we're going to do this in two ways. In Ansible, there are two very useful modules. There are basically the copy module, which is a very good way to sort of deploy and manage a static file. Something that typically is not going to change or something that doesn't need variables injected into its content. This could be maybe a configuration file for a service. It could be some sort of static file. Maybe it could be some type of content like a zip or tar archive, etc. When you move into needing to actually template files, when you want to take in information and data from multiple other sources, you really want to start using what's called the template module, which uses the Jinja 2 templating language. But let's, for now, with the standalone playbook, let's just look at the copy module. So this is the syntax. It's pretty simple. And we're going to manage the index.html file, which is going to wrangle our web content. We're going to make sure that the destination for this file lands in var www.html, and we're going to ensure that the owner in the group of this is the Apache user. So back to our standalone playbook. This is exactly what we want. And let's just take a look at our index.html file. Pretty simple. We're just going to deploy this, and it's going to basically take a set of systems that don't have anything installed to installing Apache, restarting it or ensuring that it's running, and then deploying this latest content as the web content. So let's go ahead and run this. And we're going to run packages HTTPD content. And it will hopefully do what I just said that it should do. So Apache's not installed or configured at this point. It's going to each of these systems, and it's installing Apache, and it's starting Apache, and then it's going to copy this index.html file into the root, the web root of Apache. Okay, so we see that our handler fired off as well. That's good. That's because it detected a change. And if we were to run this again, of course, really nothing should change because it has all of the packages installed. They are the latest version, and it has our web content. So we're going to see green across the board, and we see that nothing actually happened. And that's really what we want to do with our playbooks. When you start to write your own playbooks and you move into this realm of transforming systems, you always want to ensure, it's not always possible, but you always want to aim for true idempotency. And that's what we have here so far. So let's take a look at our new web content. Okay. Now this is one of our web servers. This is the IP address of host 01. We see that our web content is deployed. Okay, let's go to the second one. All right, same thing. It's identical. Excellent. Okay, so we're going to move on to a more advanced approach. This is going to be using the template module instead. And at this point in the chapter, we are going to move to a combined playbook. We're going to get into why that you want this, and we're going to cover some of the design choices that you should consider. But at this point, we've sort of outgrown our single playbook usage, where we have one YAML file per sort of task. Now we want to combine these into, sort of one solution for a specific purpose. So the template module is similar in syntax to the copy module. Again, you want to have index.html, but look at the difference here. We have a .j2 entry. Now, this denotes that this is a Jinja2 template. And again, the destination is the same, the owner and the group. This is sort of the bare bones template logic structure. Okay, so let's kind of look at this in practice. So right now we are in a directory that has just standalone playbooks. We have one for content, we have one for packages and users. So let's sort of get into the combined playbook. All right, now this is the structure that you sort of want to move to, and I'm going to cover why. But I want to show you the Jinja syntax first. All right. This is going to be the Jinja syntax that we just covered. But don't worry about this other stuff. We're going to cover this. All right. So back to the Jinja2 syntax. I'm giving you an example here of how to sort of conditionally populate your content with Jinja. This snippet of code is taken from my Ansible Nagios playbook, which deploys the Nagios monitoring system. And what you should glean from this is with Jinja, you can duplicate blocks of code or content or configuration file syntax by using things like for loops, where we can reference, say, items in the inventory file, and then we can iterate across those items, and we can run certain things. Don't worry if this is a little beyond the scope of complexity of this chapter. This is just purely sort of an example of some of the things that you can do with Jinja 2. So for example, this iterates through all of the hosts listed in the Jenkins group in an inventory file, and it creates over and over again for every one of those hosts, it creates this configuration block with the host name, which is going to be unique. And specifically, it's also going to look up the IP address of that host as well. This would save you having to manage, say, a gigantic file that has hundreds or even thousands or hundreds of thousands of these sort of entries, because Jinja is going to template this for you automatically. And then simply removing or adding a host underneath this in the inventory is going to add or remove the final result, which is going to be a templated configuration file. A little lower down here, we are doing conditional templating using a variable. We are saying that if the setting Jenkins uses proxy is true, then we want to drop this HTTP check down. And this could be set on a per host basis or somewhere else. But again, this is just an example of when you want to take the next step in managing service content and configuration file content and file content across a myriad of services. The template module, and inside of this template module is this Jinja 2 syntax, is extremely powerful for automation and for saving you time.